Hi, in this Let's Create series, we're creating a Crossy Road clone like this. In the last episode, we added the procedural generation of the road terrain. Now we'll focus on getting the collisions working and add a basic UI. Let's get started. Our character is the moving object with the collider that we want to detect collisions with the vehicles with. So what we'll do is add a script to that to detect the collisions. On our character, we choose Add Component and let's call our script Character to keep things simple. Save this in our script directory to keep everything clean. Now let's jump into the code. For now, we'll need two references here. The first is to the game manager, as we're going to need to let it know that we've died. The second is going to be our character object. This is of type GameObject because we'll simply be disabling it when we're dead. In the following video, we'll also spawn a particle effect, but let's not get ahead of ourselves. The core logic here is going to happen in onCollisionEnter. The prototype for this is that the collision is passed in. You may be asking why I've chose to do this with a collision rather than just have everything as a trigger, since we're not doing any physics. The only reason for this is that I want to adjust the particles emitted in the death animation depending on where we were hit from. The collision enables us to work this out, whereas the trigger only tells you that a collision has happened, not where. Now we don't want every collision to trigger our death, only the collisions with the vehicles. This is especially important because the cubes we use to create the road and grass have colliders on them, which we'll need for our particles later. We certainly don't want walking to kill us. There's a few ways we could do this. Either we could update our collider so it only interacts with a layer we assign to our vehicles, or we could add tags to our vehicles and check that here. I'll go with the second one, not the most performant, but it shows a concept. So we get the game object on the collision and then use the compare tag method. Here we pass in a string of the tag. Let's call it something nice and easy to remember, vehicle. If that's true, and the character game object is active, which you can get with active self, then we want to do two things. First, we'll disable the character with the character.setActive false, so we'll no longer be able to see our model. Then we'll tell the game manager that we've died by calling GameManager.playerCollision, which we'll create in just a second. Note that we had to check for the character being active because we don't want to keep running this code, only the first time we're hit. Before we go to the game manager, we'll add one extra method here in the character script. Once we've died, we're going to want to restart the level, so we'll want to reset the character. For now, this will be simple. We create a public void reset. It's public because the game manager will be calling this, then call character.setActiveTrue to turn the character model back on. That's it. Let's jump over to the game manager. At the bottom of the game manager script, we can add that new method. It's a public void player collision. All we'll do here is set the game state to gamestate.dead. That will mean we can no longer control the movement in our update loop. As you flesh out this project, you'll likely do other things here, like show a death screen, play a sound, etc. Let's jump back into Unity and get the vehicle tag set up. On the new character script, we can drag in the game manager and the character game object so the references are set. Now let's jump into our vehicle prefab. You can see in the inspector at the top there's a tag option. Here we can click Add Tag and we can add a new tag called Vehicle to match what we added into the code. Then on each of our vehicle prefabs, we can now select this tag. Let's hit play and check this out. Moving around doesn't kill us, which is a relief. But when we're hit by a car, we disappear. Excellent. Naturally, we now need a way to restart the level. Let's drop out of play mode and into the GameManager.cs script. In our new level method, we want to make sure that when we restart, the character becomes visible again. So after resetting the character position, we call our reset method. To do this, we use character.getComponent and the type of the component we want to get is character. Then we can call the reset method. If you access this a lot, calling getComponent all the time isn't very performant. But in this prototype, restarting a level isn't a common occurrence, so this is fine for now. As we don't have a UI yet, let's add in a key press to reset the level. So in our update method, after doing our movement, we'll have an extra if statement to check for this. Firstly, we ensure that the game state is dead, because I don't want to restart partway through a level. That's not strictly necessary, it is a shortcut after all, and the space key was press this frame, If all that's true, then we call our existing new level method. Remember, that was designed to remove all the game objects and reset all our variables before generating the level, so it should work great. Back in Unity now, we can simply jump into play mode to test that out. Pressing space when you're alive doesn't do anything, but after dying, I can press space to restart the level. Awesome! You can see we've got a completely new level this time. Let's jump out of play mode. All we need now is a UI to tell us how far we've got. To show our score, we simply need one UI label. Right-click, UI, Text, TextMesh Pro. This is our first time using TextMesh Pro, so we'll get the importer pop-up. Just import the TMP essentials and then you can close that box. I'll switch to Game View so we can see how the UI looks on the exact scene. The text is currently in the bottom left. We'll click the Alignment widget, hold Alt to also set the position and anchor it to the top center of the screen. Let's just put an example score in there of 1, 2, 3 so we can see what it looks like. It needs to be bigger, so I'll up the size to 50. At this point, I'll note the size of this text will by default depend on your resolution. I'm in 4K, so it's small. What I like to do is if you open the canvas, then you can see the canvas scaler property. At the moment, the UI is set as constant pixel size, so 50 pixel text will be a lot smaller on say a 4K than 1080p. So we can change this to scale with screen size. I'm not worried about the reference resolution at this stage. Now we've got the text about the size we want. Let's align the text to the center and make it bold. I'll just move it down a little bit to y = -50 so it's not so tight to the top of the screen. You can play with the UI look and feel as much as you like. I'll set the value now we're happy to 0 as that's what it'll start with. And I'll just rename this score text so we know what it is in the hierarchy. Let's jump into the game manager now so we can track the score and update this. In our variables at the top, first we should get a reference to our score text. So in our game objects section, we'll add a new serialized field of type tmpro.textmeshpro.ugui. That's always a mouthful, called score text to reference our UI text. We will also need to add a new variable to track the score in our private variables at the bottom. We can't just use the character.y position, as the player can go backwards, but the score shouldn't go down when they do that. So add a new private int score, which will start at 0. Then in our new level method, we need to make sure we remember to reset these two things related to the score. First, we can set the score to 0. Then we can set the score text.text to the string 0. The only time the score needs to update is when we move. So in our update method, in our if statement where we've just chosen to move the character, we can check if we also need to update the score. To do this, we check if destination.y + 1 is greater than the score. The +1 is needed here because our first procedurally generated road is at y = 0, and ideally we want the score to start counting at 1. If it's true, we're the furthest along we have been yet, so we should update it. We update our score variable to be destination.y + 1. Then we can update the score text using the .text property to set it to score. There are many ways you can get an integer to a string, but I like to use format strings, which in C# are prefixed with a $sign. Then you can just put the variable in curly brackets, and C# handles making that variable a string for you. That should be all the code we need to update. Let's jump back into Unity. On our game manager, we just need to drag on the references to the score text. Now we can hit play and try it out. It goes up as we move, and moving backwards doesn't change it until we progress further again. If we die and reset, it goes back to 0, which is good. That's it for this episode. In the next, we'll add on the particle effect that I keep talking about. I hope you found this tutorial useful in some way. As ever, the full code is on GitHub and linked in the description below. See you next time.